Community of Practice webinar series presented by the ARIES team, that is Artificial Intelligence for Environment and Sustainability of BC3, that's Basque Center for Climate Change in collaboration with UNEP and UNSD. The topic of the day is ARIES for SEEA, for rapid natural capital accounts generation towards fast, transparent, and standardized, yet customized ecosystem accounts. The Community of Practice family, together with the World Bank, would like to start by thanking our partner institutions, individual members and countries that make this Community of Practice possible, contribute and provide a platform to discuss policies and national development plans related to natural resources, environment, climate change, through the lenses of the implementing natural capital accounting tools across Africa. In today's webinar, we are pleased to have a team from BC3, UNEP, and UNSD to present a web-based developed application in support of the implementation of the system of environmental economic accounting, ecosystem accounting, SEEA for ecosystem account, that was adopted in 2021 as a statistical standard. The Community of Practice, together with member countries and partner institutions last year, carried out a needs assessment to better understand what NCA accounts work is needed and prioritized, can be prioritized. And among the key priority accounts and capacity needs assessment that was done, SEEA for ecosystem account was among the first top priority accounts identified by member countries in Africa. So this webinar is timely, and this learning webinar will help us to learn more about ARIES and how it can and it may help users, in this case I mean member countries, to develop SEEA ecosystem account within their respective countries. We are pleased that in today's webinar, we will learn how the ARIES for SEEA Explorer will help member countries and institutions to start compiling ecosystem accounts, and also, and interestingly, and more importantly, that this ARIES for SEEA Explorer application, it can help to do it less costly, and this is really what is needed in most of the African countries. So I invite you all to participate and interact with the resource experts here today to help us, educate us, and share experience and case studies on how ARIES for SEEA may support countries to develop their respective ecosystem accounts within their respective countries. I would like to thank you all for joining and getting interested in this important webinar, focusing on advancing NCA in Africa. And I am sure that the outcome also of this discussion will advance our NCA work across Africa. Let us have a productive discussion. Allow me also to thank the presenters, the team that is presenting today, that's behind this work and contributing to advance NCA in Africa under the Africa NCA Community of Practice. Thank you all, and I wish you a productive webinar. Over to you, Monica.
Thank you, Peter. Good morning and good afternoon, everyone. This is Monica Lopez. I am based in Nairobi in the United Nations Environment Programme in the Economics of Nature unit. So thank you so much for joining, and thank you, World Bank, for hosting us today. And thank you to all the participants of the African Natural Capital Accounting Community of Practice. I hope we'll have a very successful session. Could I ask all participants to mute their mics, although I'm not sure anybody has the choice to leave them open. And if you could please post your questions in the question and answer button, and we will attempt to answer them. After every presentation, we will have the opportunity to ask questions to the speakers. So as Peter has mentioned, we're going to be working on the ARIES for SEEA This came about also with the support of the Natural Capital Accounting and Valuation of Ecosystem Services project, which was developed by the United Nations Statistical Division, and Bram coordinated, and he's about to speak now. Sorry, somebody says they cannot see the mic. Exactly, I think we don't have the option to speak openly. Sorry about that, but you can post the questions in the chat. So the Natural Capital Accounting and Valuation of Ecosystem Services project was developed in 5 countries, one of which is in Africa. And in addition to this capacity building session that we're doing with the community of practice, we will also like to do an in-person training, hopefully coming up in July for 5 more countries. So we're hoping that after that, we will also be able to share some of the results of the compilation of the accounts. So Bram is a senior statistician. He works with the United Nations Statistical Division based in New York, and he was the coordinator of this NCAPES project. So over to you, Bram, for the introduction on the system of environmental economic accounting. Thank you very much.
Yeah, so thank you, Monica, and hello, everybody. I'm quite excited to be with you all here today. So let me try to share my screen. Can you see it now?
Yes, we can see it.
Okay, perfect. So, yeah, hello again. So with this short presentation, I wanted to provide some broader context on the system of environmental economic accounting, ecosystem accounting implementation strategy. Sorry, that's quite a mouthful. And the ARIES and the role of ARIES for SEEA herein. Yeah, so as you probably know, after an inclusive multi-year process with participations of hundreds of experts, statisticians, ecologists, economist modelers, we reached a major milestone last year with the adoption of the SEEA ecosystem accounting by the United Nations Statistical Commission. And it received attention at the highest political levels, including from the UN Secretary General, Antonio Guterres, who called it a historic step towards transforming the way how we view and value nature. And in his UN Common Agenda, which basically sets out a roadmap for the next 5 years, with priorities, he underscores the need for new measures to complement GDP, but he also urges member states and others to begin implementation of the SEEA ecosystem accounting. And here too, we've developed an implementation strategy, which was adopted earlier this year by the UN Statistical Commission. So the overall objective of the implementation strategy is to scale up the uptake of SEEA ecosystem accounting with a target of at least 60 countries implementing at least one type of ecosystem account by 2025. And to put that into perspective, we run also an annual survey on SEEA implementation, covering both the central framework and the ecosystem accounts. And we now have 90 countries compiling SEEA accounts, out of which about 36 have started compiling the ecosystem accounts, although the scope of it can be quite different from countries. So specific objective, well, first of all, regular production of selected ecosystem accounts. Then secondly, so-called mainstreaming biodiversity and ecosystems into national or subnational policy making. That is, we need to ensure also that the accounts that we develop respond to policy needs. And then thirdly, the use of the SEEA for monitoring and reporting, in particular, for instance, for biodiversity, the NBSAPs, the National Biodiversity Strategies and Action Plans. And I wanted to mention here also that the SEEA is proposed also for deriving several of the post-2020 Global Biodiversity Framework indicators. So secondly, for informing the VNR, Voluntary National Reports that present country progress towards achieving the SDGs. And thirdly, also in the context of climate change, supporting, for instance, reporting on the national determined contributions, the NDCs. So the approach and main principles are the following. Well, first of all, multi-stakeholder engagement. So at the national level, very important. but also at the international level. I think also, as for instance, showcased here, where we have a collaboration across several institutes, the World Bank, UNEP, the UN, regional commissions of the UN, and also academia and so on. Secondly, following a flexible and modular approach. So it's not necessary to compile all the accounts at once, but start with the ones that are most policy relevant. Thirdly, a tiered implementation. So the accounts don't have to be perfect right from the start. So we advocate using, starting with releasing basic experimental accounts, for instance, using basic models that can then be gradually improved over time. And then fourth and fifthly, follow a regional or sub-regional approach, stimulating also South-South collaboration, facilitating cross-country collaboration, for instance, benefiting from countries that may speak the same language. And we intend to also support it. So in addition to the annual global fora that we organize on the SEEA, the accounts, but also the policy forum that we do together also with the World Bank and others. We'll also organize regional fora to facilitate the countries sharing their experiences. So the global implementation strategy has a number of activities in support also of country implementation. Well, first of all, capacity building, very important. So we've developed e-learnings. So actually, as we speak, there is an e-learning on ecosystem accounting taking place in collaboration also with SEEA, so a training institute of the Asia Pacific. But we'll also be translating the e-learnings into Spanish, doing a training workshop in the coming months, and also in French. And that will be after the summer. Secondly, we're also developing guidelines and materials to support compilation. So we actually just released the guidelines on biophysical modeling. And these guidelines cover ecosystem extent condition, but also selected ecosystem services. And we'll be releasing shortly also guidelines covering the monetary valuation of ecosystem services and assets. I mentioned already the importance of strengthening collaboration. Also, an important element of the implementation strategy is also to develop data and tools. And this is, I think, where the ARIES for SEEA also comes in. And then last but not least, also, communication and advocacy is really important. So now turning to the ARIES for SEEA, Monica already mentioned that it was developed as part of the NCAPES project by the Basque Center on Climate Change, the BC3 team, building on their decades-long experience on developing this ARIES platform. And I'm sure we'll hear a lot more about it by Ferdinando, Ken, and Alessio later on. But also important, I think, from our statistical community perspective is that it's also very much linked to statistical innovation, for instance, to the UN Global Platform on Big Data for official statistics. A beta version of the platform of the ARIES for SEEA was launched about a year ago, and it's being continuously expanded. So why did we engage also with the BC3 theme in developing ARIES for SEEA? Well, first of all, there are already several platforms out there, most of which basically have fewer functionalities, but we really saw the need also for a computational platform. Secondly, lowering barriers to compile ecosystem accounts for countries. So rather than wait several months or even years sometimes to get to results, because it can be difficult, also involving GIS, expertise and so on. The idea here was to also generate some basic results quickly that can then also be used to generate interest from stakeholders and then gradually improved. Thirdly, make it easier to collaborate, both in terms of sharing data, but also by co-developing models. So moving away from a situation where, for instance, experts work in silos, they develop a model, release the results, and that's it. To this collaborative mode. This is what we also mean with sort of moving towards interoperability. And I think Ken will also say a lot more about that later on. And then fourthly, to facilitate deriving indicators using a solid basis in accounts. So that's what I had to share with you today. If you have any questions, please put them in the chat. Thank you so much for your attention. Back to you, Monica.
Thanks a lot, Bram. And thanks everyone for your attention. So in addition to the chat box, please note there's also like a Q&A button that you can press and also post your questions there. Well, we don't have any questions in the chat so far, and we don't have any questions in the Q&A, and the mic function does not work for the participants. However, some people did send some questions online. So if it's okay, I will go ahead and read out one of those, and I'll hand it over to you, Bram. But if you prefer that somebody else from the rest of the team responds at the end, we can also do that. So the question is, how is the World Bank or UNSD or BC3 using ARIES and SEEA and the resulting ecosystem accounts with clients? Specifically, are they used as a source material for individual project design or for systematic country diagnostics and country partnership frameworks? And will they be used for climate change and development reports? Indeed, that's the question.
Yeah, I cannot speak on behalf of the World Bank, of course. So I think from our perspective, we see, the ecosystem accounts as having multiple uses in terms of, I think, both in terms of informing different types of policies, macroeconomic policies, but also sectoral policies. And because the ecosystem accounts have this spatially explicit basis, they can also be informing, I think, quite a range of sectoral policies, including things also like land use planning and so on. And in addition to that, what I put in my presentation also, we also see, I think, quite a large potential to inform also these main environmental conventions. So in terms of biodiversity, climate change, and so on. So I think that, there are multiple uses, and I think it also very much depends on country priorities, on what they, how they want to see, want to use these accounts. So in terms of developing these accounts, it's therefore very important, to set up, for instance, also, stakeholder groups to make sure that, the accounts that are being prioritized for development also respond to these policy needs. At the same time, we also see a lot of potential to generate what we call global databases using ARIES for SEEA, with the idea, for instance, that, we can the global databases, and we just started a big program of collecting also, we are going to collect also, for instance, energy accounts, air emission accounts, and so on. But for us at UNSD, it's key that this is always official statistics. So it means that these data, before they are sort of put in the global database, are vetted by countries. But here we see potential for ARIES sort of to impute or jumpstart basic results that then are shared with countries for their official endorsement, and then they can be put into a global database. So let me stop there. Thanks. I hope it was answering the question.
Yeah. I think that was very thorough. Thank you so much, and thank you, Lawrence F. Connell, for the question. There's another question that was placed in the chat, and from Akil Carlos Defo. Hello, everyone. How to join the UN Global Platform on Big Data? Does anybody know to that?
Yeah, let me, perhaps, Monica, I can put some links in the chat later. I can look it up and get back to the.
Perfect. Thank you so much. And then there's one last question, which also will require, I think, more detail, but it's a very good question. I would like to know the methods applied in determining the monetary value of ecosystem services, like ambient temperature, oxygen, daylight. Over to you, Bram.
Yeah, so perhaps just to say that in terms of some of the points mentioned here, they do not, sort of the ecosystem services that we conceptualize in the system may be a little bit different than what is suggested here. So we're really talking about, the main categories of things like provisioning services, crop provisioning services, water supply, and so on, regulating services like carbon sequestration or carbon retention or water purification, and cultural services like nature-based recreation. So we, as I mentioned in my presentation, will be releasing a technical report. So they're not official guidelines shortly that will basically for each of these ecosystem services, and we have a reference classification in the SEEA ecosystem accounting of about 25 key ecosystem services. It provides suggestions on what methods to apply. And this will be released, I think, in June. So please stay tuned. A key thing from the accounting perspective is that we really focus on, obtaining monetary values that are consistent with the system of national accounts. And this means that they capture what we call exchange values. And those are different from welfare values, as they exclude this consumer surplus. So that's sort of important to, I think, keep in mind also, what the purpose is for when you undertake monetary valuation. We always do recommend, and that is also very much sort of part of the system, that you start with the compilation of measurement of ecosystem services in physical units, and then you can take the step towards valuation. And that's, I think, also, as you will see in a bit, also how the ARIES for SEEA is structured. So that you have also always the underlying physical ecosystem services that you can model. Thanks.
Thank you so much. And thank you, Arina A.M. Jobe, for your question. So I think we don't have any further questions for Bram, but please, either through Peter, through the community of practice, which Bram is also a part of, or through the emails that we can share, please feel free to get in touch with us about more questions. And now I'm going to pass over to the next presentation. This will be a presentation, a demo, in which we'll see ARIES, the integrated modeling platform to democratize knowledge and information. Ferdinando Villa, who is a researcher from the Basque Center for Climate Change, BC3, will be presenting it. And I just want to share some more information on Ferdinando. He has dedicated his scientific research to enable comprehensive environmental assessments and decision-making by building artificial intelligence approaches capable to integrate different areas of knowledge. Such as ecology, biology, sociology, and economics. He is the creator. He's the creator and leading developer of ARIES. So thank you very much, Ferdinando, and over to you.
Thank you, Monica, and very nice to hear about myself from you. Unfortunately, I'm still unable to share my screen, so I'm severely limited, but I'm only expecting to do a small introduction on what ARIES is and what actually brought us to build the platform, and then leave it to Alessio and Ken for the more specific discussion and the more specific demonstration. So I will not demonstrate anything because I'm unable to, but what you're looking at is courtesy of Alessio's sharing screen, an infographics that you can find on our website that basically gives you an idea of the underlying rationale below all these efforts that have basically convinced us that ARIES was a necessity. And what you see on the left, the jumble of complexities there is basically the situation that we try to obviate using the platform. The first, I will just mention these problems that are not only in natural capital accounting or in ecosystem service assessment, but very much all across the board in all scientific activity, particularly having to do with policy and society. So first of all, the inequity in the access to scientific knowledge. And we all know that is more difficult for some people to obtain information, data, models, and expertise than for others. And obviously, if we want sustainability, there is no excuse to be brought for not making the access to knowledge as fair and as democratic as possible. So the first thing that ARIES wants to do is a platform that is a collective, collaborative platform where everybody can stay the owner of their own information, data, and methodologies that they know are right for their own context, but at the same time provide those that same information to the rest of the world, so that an automated platform is able to pick the proper knowledge for each specific context, but at the same time inform other contexts about what has happened in each of them. So you can read on this infographics in better words than I can mention now, but that is the main motivator for building ARIES. The second part is the fact that policy is very rarely informed by an holistic and overarching view of the socio-economical problems that policy is supposed to regulate. And the reason is availability of information and the difficulty in integrating information that speaks different languages, because what the economists can tell you is different from what the ecologists can tell you, and the same words mean different things if they come from different kinds of experts, even if you have all these experts at your disposal. So that brings us to the point below it, which is we try by using semantics, explicit semantics, and you will see some examples. Particularly Ken will talk about how we use semantics in order to democratize access in science, the access to science. We try to remove this compartmentalization and to basically build a common language so that using an automated approach that doesn't need humans and that doesn't need consultants and doesn't depend on differences of languages and availability of the resources needed in order to contract different professionals, is able to align the knowledge from different disciplines and align the knowledge needed for policy with the outputs of science, so that we can enable complex dialogue between different sciences and policy in the most automated way possible. One of the main issues when you try to build an approach like that is that very often it's very difficult to convince people that that approach is good, because those approaches are necessarily complicated. And the black box effect is what really turns people off, because if you don't understand what the machine does and what the how the connections has been made, it's very easy to lose trust in the approach and to think that you're basically being played into the goals of somebody higher up than you, which is why one of the most important parts in ARIES, which is made possible by the fact that everything is semantically annotated, so the machine actually knows the meaning of all the information that goes through it. The main goal is transparency, so we provide very, very good records that explain after each account, for example, or map or model has been calculated, everything about that model, why it was chosen, what are the references that you can justify what has happened, and the exact provenance of all the data that have been used, and sometimes even the alternatives that haven't been taken. So the user of ARIES as not only to find the information, but also to ensure that everyone can build the most trust about the outputs that have been computed, and can also actually interactively and dialectically connect with them and suggest different approaches in case they think that the approach is not the right one. The research that has inspired a lot of technological platforms so far has mostly been motivated by the industry. So we talk about artificial intelligence because and big data, because there's been, Twitter, Facebook, etc., basically developing all these algorithms in order to get richer and richer. which isn't exactly our goal, obviously. We try to use that same approach, but in the most transparent way possible, not to build a new knowledge based on analyzing the behavior of people, but to integrate human knowledge, which is a very different approach. So the artificial intelligence that it uses today in most situations tries to extract information and use it in non-transparent ways. In our case, what we do is to try to extract from scientists the best of the knowledge that they have related to contexts specific or generic, and then put it in a machine so that that machine can take all these different components, integrate them into models that didn't exist before, but are able to answer more and more complex questions. And the more knowledge you add to the machine, the more questions can be answered. So it's really an approach that is oriented not to the industry, not to extracting values, but to actually maximizing the value to society. And basically that's the entire point. So this last piece, when we talk about the use we do of artificial intelligence, instead of centralizing control and basically trying to use artificial intelligence in order to extract things from society, we try to build a new society that is actually informed by knowledge in ways that were not possible before. And I hope that the demonstrations done by Alessia and Ken in a minute will convince you that this is what we have achieved. But even if we don't have achieved, if we haven't achieved that yet, our hope is that you can see the effort going into that direction, and you can trust us enough to want to work with us and to contribute to ARIES and to all these activities, because those activities are absolutely nothing without their users and without their contributors and the people who actually make good use of them. So thank you very much.
Thank you very much, Ferdinando. I'm sure it would have been different if we had a demo, but actually, yes. I think this was very, very useful, knowing all the different aspects of what ARIES entails. So thank you so much for that. I see there are no questions in the chat. Thank you, Bram, for posting the link to the Big Data Center. Okay, so there are questions, thank you, in the question and answer. From Fadeke Ayula, is there a fee to use this platform? Ferdinando?
No, and the thing is, the platform obviously has costs, and it's been largely so far funded by public grants, and so there are no fees. Our idea for the platform is that it should stay free for anyone who doesn't make money out of it. And it is possible that in the future there will be industrial users, for example, or consultants that can use it to do their job. And in that case, they could probably pay a fee, but the fee would go to making the platform even more available and more powerful for the nonprofit users that can access it for free. Our idea is that it will stay free forever if the user doesn't make money out of it, but it only uses it for public purposes.
Thanks for that. And thank you, Kenneth, also for responding to the message. There's another question from Arena Joby. What is the level of adopting the environmental system of accounting globally and regionally? Sorry, this might be more for Bram, and I think he briefly mentioned it. So I'm wondering if we can take this one to the end, if that's okay, when we are done with the demos and the presentation of ARIES, and we can then address again like what the uptake of the SEEA is. So maybe just one comment, Ferdinando, it is free, but maybe training is always useful, right? Before countries or people decide to start working on it.
Well, yes. I mean, the training goes in very many different ways. But the thing is, if you want to use it to calculate official accounts or to help calculate that, training is obviously important, because you need to make sure that you understand exactly how the platform works. Because otherwise, if you build official information, you really want to be aware of all the details. Obviously, it's a web application that, as you will see, is fairly intuitive and simple to use. And so we have several levels of possible training. The basic level, we are happy to give training in using the platform, but it doesn't necessarily is not necessarily required, because it's not that difficult to use the platform as a user. Then the moment you need to add the new data to the platform is another level of complexity. It's not difficult, but at the moment some training really helps you doing the right thing. Also because the system is very general, you can use any kind of data, but the data need to be very well prepared, because the platform doesn't tolerate errors and projected files and this kind of things, because it's an integrating platform. In order to integrate things, they need to be completely up to speed in terms of having all their information completely defined, metadata, etc. So training can be useful in that sense. And the third level is when you actually want to change or add to the methodologies, to the models that are in the machine. And in that case, you obviously need to work with us or learn some significant material, because you need to code models in the language that the platform uses. You need to understand the semantic modeling paradigm, etc. All it's doable, and we are committed to providing all three kinds of training, but they go in increasing level of difficulty. And I think just for using the platform, training is good, but and advisable, but not necessarily absolutely necessary.
Perfect. Thank you for clarifying that. Thanks, Ferdinando. So I see there's also a question regarding data sources, and I'm wondering if we can bring that question to after Alessio's presentation, because that might be addressed, and we can talk about the different types of data that will be needed for this platform, if that's okay. So I'm going to hand over to Alessio Vulcain now. He's also a researcher from the Basque Center for Climate Change in Bilbao, and he's going to present the ARIES for SEEA web-based application, how to develop fully transparent and automatic compilation of ecosystem accounts. So Alessio is the responsible person for the natural capital accounting in the ARIES team, and he has supported the development of ARIES for SEEA in the past 2 years. So thank you, Alessio, for this, and over to you.
Thank you very much, Monica, for the introduction. This is the presentation that I have prepared for today. I think many of the points which I wanted to discuss have already been addressed. So I'm maybe going to skip or go faster in the first part of the presentation and start already with the demo. Just for you to know, again, to repeat, that the SEEA framework represent the methodologies that have been used by the system that I'm going to show you in a minute, and is the official system that was endorsed as an international statistical standard in March of 2021 to compile ecosystem accounting. What is ARIES for SEEA? ARIES for SEEA is the artificial intelligence solution that provides the infrastructure to integrate data and models to answer questions, in this case, to address the problem of compilation of ecosystem accounting according to this methodology. We have seen already, Bram has anticipated some of the main characteristic of the system, which allows for rapid, standardized account creation. The system uses mainly at the moment global data, but models and data can be customizable. And so if there is availability of local data, knowledge, and models, those can be integrated in the system. Nevertheless, at the moment, we can still compute ecosystem accounting anywhere on Earth. This system is faster and easier to learn when compared with other biophysical modeling approach. And also, as you will see, there is a very easy to use application that supports the implementation of the system of environmental economic accounting, ecosystem accounting. And also the system produce automatically, leveraging on the artificial intelligence, accounting tables, maps, and reports, which I think are very useful, especially for decision makers, and offer the infrastructure that can be used in general by the SEEA community to share and reuse interoperable data and models. So again, this is to remark all the concept that has already been introduced previously by Ferd. This said, let me switch to the system. I will show you how this works. So this is the, by accessing this link, you will be able to access the application. You just need to be registered, and then once you introduce your username and password, you'll be prompted to the main page. This that I'm showing right now is the K Explorer, which we can say is the naked phase of the system. We are now going to use what is an application. There are more, but in this case, I'm going to show you ARIES for SEEA Explorer. That, as you can see, is the application that sits on top of this normal map user face. And as you can see here on the left, there is a panel which can be used to set the context and decide which outputs you want to obtain from the application. First of all, for spatial explicit analysis, we need to identify three main dimensions. The first one are the geographic boundaries of your analysis. This can be done with the map boundaries, which will take into account all the area that is shown in your screen. Otherwise, you can also pick an administrative region, which is going to identify the biggest administrative entity in the area that you're browsing, or even we can go, for instance, using, river basin, which will set the context according to watersheds. There is even like another option, which we're going to use now. You can type in the name of the country that you want to explore, and the system can automatically go to this region. In this case, as you can see, by zooming in and out, the resolution adjusts to the level of, suggests, let's say, a level of resolution that is good for the context that you're exploring. In this case, let's go back to Ghana. We lock the spatial resolution in a way that even by zooming in and out, this doesn't change. But be aware that the resolution can be set manually here. And you can also decide to use meters or kilometers. Then this takes care of the dimension of granularity. Then there is also the temporal dimension that needs to be taken into account. So for instance, in this case, we are observing a dynamic context, a multi-year analysis. If we just uncheck this button, we obtain a static analysis. In this case, let's go on, for instance, do this from 2012 to 2015 in Ghana. And this, our context is set. What we have to do next, what we can do is the study setup, which is basically picking among the macro group of accounts that are available in the system. I will start, for instance, computing extent account, the additions and reduction, and the change metrics, still for ecosystem type. And as you can see, there are also other accounts like the land cover accounts that can be compiled. There is also information on the condition account. In this case, forest condition metrics need to be selected, and you can choose any of these combination. And once you've done this, output becomes available and the system can compute those. And we also have ecosystem services accounts in both physical and monetary terms. Not all the monetary terms are available for all the physical system. For instance, that is the case for sediment regulation, for which there is not yet, let's say, a standard for its computation, so is not evaluated at this moment. As you can see, talking about the transparency of the results available in ARIES, you can see that this part to which the system automatically switches once the results are completed shows the tables that you selected, in this case, again, to additions and reduction and the metrics of change of the ecosystem types over the period of time selected. We also have information about the maps that shows the main output that have been produced. In this case, you see the map of ecosystem type. And there is another tab that shows which are the resources used. So in this case, you can see that we're using Global Aridity Index, Global Mountain Explorer as a CCI, that is the global land cover, and global elevation data, and mean and early temperature. There is also another important feature, which is the data flow, which is a diagram which shows how the model has been computed. At each step that is taken by the system to produce a certain outcome, this being intermediate or the final one, is here described. And as you can see, for instance, in this case, to construct the ecosystem type, we take several ecological variables into account, this being elevation, land cover, aridity, and those are let's say, put together into a multi-layer lookup table, which then gives the final results. As you can see, these green boxes represent the data. Whenever there is a classification or there is a change, that is a transformation that is done to the data, this is also highlighted here. And then, for instance, we can see again a lookup table. In a moment, I will show you this in the report, which I think is more readable than this, but this is to give an idea that everything is fully documented and there is provenance of both models and data used. So going back to the last tab of the document view tab, we have the report. In this case, this is automatically created and shows results for the ecosystem extent, because that's the main output that have been produced. But this gets compiled automatically as we add new models as we require the computation of other models in the system. There is an introduction, there is a method. As you can see, this is the table, the lookup table that was shown before. So the information is also available here. There are the results, and there is also a discussion reference and an appendix for to give further information on all the modeling developed. All this information is downloadable as a PDF, and moreover, each of the layers that have been computed by the system to answer your query are also available. In this case, there is the land cover, there is the aridity index, there is the mountain. So this is the same for all the inputs that have been used. As you can see, these very nice maps are here presented, and all of these inputs can be downloaded either independently or by clicking on this button here. This is true both for tables and maps. If you want in the maps, there is also the option to download it, to copy into direct an Excel spreadsheet or download it. And what is shown here are the key SEEA outputs, which are automatically identified. Another interesting feature, and I'm gonna show here because I'm not so sure if you can see this from this view, but I think now you can see that also maps are actually interactive and change as the model moves from one year to another. I also want to show some pointers here, which I think are useful. There is a user guide here at the bottom right corner of the application, which basically gives you an overview of how to use each of the accounts that are currently used in the system. There is also further explanation on how these are built. And what I want to point out is that the system is not only, let's say, constrained to apply methodology for the SEEA, even if this was clearly the main output for the application. We are also happy to integrate other indicators. It's the case, for instance, for SDG and CBD, and you can see that by using this feature, these additional indicators get already available here, and with a simple click, also this gets computed. This is all which I wanted to show you for this quick demo, and I'm happy to take any questions if there is any. Thanks.
Thank you very much, Alessio. That was very interesting, and I think it was very good for us to see exactly how it would work in the platform itself. So Ken has been very efficiently responding some of the questions that have been put in the chat, and I think a lot of them are, yeah, they have been answered live or by Ken. So I think we are good with those, unless, Alessio, you would like to read through them and see if there's anything you want to add. If you want, meanwhile, what we can do while you read through those questions, maybe we can pass over to Ken's presentation, and then after that, we can open the floor and make sure that everybody's questions are answered and see if anything else comes up. I hope that sounds okay.
Yeah, that's perfect. Thanks.
Thanks a lot. And thank you, Ken, for answering all those questions while the presentation was taking place. So Kenneth is a research economist with the US Geological Survey. He's a longtime collaborator with the ARIES project and has led work on natural capital accounting in the United States. And his presentation is about the interoperability and artificial intelligence to standardize and scale up ecosystem accounting and advancing automatization and customization of models. So over to you, Ken. Thank you very much.
Thanks for that introduction, Monica. And can everyone see my screen?
Yes.
Okay, great. So thanks for that great introduction, both Ferdinando and Alessio. I'm going to wrap us up by talking a little bit about this general concept of interoperability and why it's important and what vision we need to carry forward for natural capital accounting in Africa and globally. So very briefly, for those of you who aren't familiar with the word interoperability, what we're talking about is the ability for independently developed data and tools to work together with minimal effort. And because SEEA is inherently a data integration exercise, at least in my view, this is a key challenge. When we work separately in different silos and our data and results and models are not easily integrated, SEEA is always going to be harder and more time consuming and difficult to compile. When we can collaborate, I think things will be easier and we'll be able to do better and better assessments. So I think this is a really important goal for the SEEA community. And one of the reasons that I've been working on ARIES and SEEA so long. So I just want to start off with some of the equity issues here. And I don't think these are going to be very controversial, but this is something I think about a lot, is that we do a lot of science in the global north. It's fairly easy for scientists with a lot of resources to do good one-time studies, but getting those best practices out globally and capacity development in the global south has remained a major challenge. And this is a serious equity issue, and one that I don't think we can ignore any longer. For countries that want to get started on SEEA, how are they supposed to maximize their success? Well, we ought to be doing everything in our power to bring the best data and models together, and to do it in a user-friendly way that maximizes the chance for success for those NSOs that want to get started on ecosystem accounting. And I don't think we've taken that as seriously as we could in the past. So I think that's why interoperability is just critical from an equity perspective. So I say that before we even think about choosing a model, you have a number of different models you could choose for different ecosystem services. We need to think about choosing a vision for the future of SEEA implementation. And I think interoperability needs to be at the center of that vision. At the same time, ARIES provides a technical solution to interoperability, which is great, but interoperability has critical human elements, and it needs to be user-friendly, it needs to be fair, and it needs to be endorsed by the community. And so we've done a lot of work. The images on the left side of this slide are some of the work we've done about the technical side of interoperability. There are folks who have written about the human side of data interoperability, which matters just as much, if not more. So that's something we need to pay attention to And having this community of practice is a great start for that, that there's already a user base and an interest in collaboration. So the interoperability strategy we developed in parallel with ARIES, we put together a document that's publicly available that talks about what do we need to do to make next generation SEEA accounting interoperable. And our vision for that is that SEEA accounts, but also related indicators for things like the SDGs and the CBD post-2020 biodiversity goals, are that all of these indicators should be easy to recompile when new science emerges, when there's better models and better knowledge about how we can do this. We ought to be able to update the results. We ought to be able to quickly extend time series when new data become available to build those time series, which are part of ecosystem accounting. And we ought to be able to do good international comparisons and at the same time be able to do good country-specific customization. And all of that ought to be able to help get the science into the hands of decision makers, including the public and the media, as quickly as possible. So there are a lot of tools out there, and you've probably heard of some of the tools on this slide. I just mentioned this because there are ecosystem service modeling toolkits, there are data viewers, there are cloud computing platforms, and there are model integration frameworks. So there are a lot of people that are looking at different aspects of this problem. But what makes ARIES different, and for some takes a little bit of time to fully understand, but what's so important is that what ARIES enables is the assembly and use of collective knowledge rather than individual siloed knowledge. We're trying to make various data sources and models interoperable. And with AI supports, those can be used more easily to implement SEEA globally. So that's really the vision and how ARIES differs from some of the other approaches that are out there for all these different types of things, from ecosystem service modeling to data viewing to cloud computing. As a practical example of what this looks like, I often start with this little cartoon that, let's say you're doing accounting for sediment retention, and this could really be any other ecosystem service, but we'll use this example. There are commonly used models like the revised universal soil loss equation, and these are often used in a number of different applications, but there are other models too that could be used. And the way we typically do this is you have scientists that are pulling together GIS data, you have scientists that are looking through other scientific studies and data sets to try to calibrate models, for instance. All of this takes a lot of time and expertise, and hopefully at the end of the process, it gets into a data repository, but this isn't always the case. What we envision with ARIES for SEEA and what we've been working toward providing the infrastructure for is that experts, instead of just publishing their data or putting their code or their data into a repository where it just sits for years and years, is that the experts are contributing their knowledge in a way that it sits on the web and it can be automatically ingested by a computer. And it's also labeled with what we call semantic content, which means that it has a very precise label for what the data set or model means. And a computer system can know when two data sets or two model endpoints, for instance, are compatible. And when we have that, when we have the data sitting online in a machine actionable format, and a computer can know what it's looking at, then when a user enters a request for a certain model or ecosystem account, the computer system, in this case ARIES, can assemble the data and models and provide the results to the user. And it can do it much more cheaply and quickly than the status quo. And this is exactly the example that Alessio talked about in his demonstration, and that Ferdinando gave us the conceptual overview about at the start. So again, given the urgency to scale up SEEA, we think that interoperability is an important way we can do this as a community. So who benefits from this? Who is this person on the left side of the cartoon who's now able to do ecosystem accounts more quickly and cheaply? There are probably many people you can think of, but ecosystem account compilers in a national statistics organization, groups focused on environmental and economic justice, for instance, indigenous or urban environmental justice groups that would have access to the web and could better compile data and models to understand where their needs are and aren't being met, or NGOs or local governments. There are a variety of particular users, but what we're really talking about is making this accessible for people who don't have PhDs, who don't have 6 months to a year and hundreds of thousands of dollars to do new studies. We want to really make this cheaper and more accessible to a wide variety of users. How do you get started on ARIES for SEEA? That we have a lot of material about this that's available, but the starting point is always registering for ARIES with a username and password, and we have a website here where you can do that. We have a space where you can ask questions and look at general tips for modeling, and we have software supports. We also, as was mentioned, have a variety of training materials. We have not done much in-person training with COVID, but that should be rapidly changing. And we need to understand better how to support data hosting and that technical process of making data and models interoperable, particularly for African nations. We need to figure out ways collectively to make more data and models accessible, and that will let us go from these global models to really high quality estimates that use the best available local data and knowledge. So I've got, I think, 1 or 2 more slides left, and then I'll wrap up here. But how can national statistical offices use ARIES for SEEA? I would argue that the starting point is to determine which methods you want to use, and if ARIES for SEEA is indeed the route that a country wants to go, understanding what data and models are available and what you'd like to use for SEEA is a critical starting point, and understanding which of those we can make public and which have restricted access, for example, which might have privacy concerns. And once we know that, we can work to make the needed data and models interoperable with ARIES. And public data sets can be made public, private data sets can be kept private, and the users who have access to those are restricted as appropriate. So there was a question about data licenses and who has access to data. We always respect the licensing arrangements of data and privacy needs. We advocate for making data public as much as possible, but we also recognize that there are needs for confidentiality, and we have mechanisms to deal with that. After doing that, there's a process of testing and validating results, and then producing accounts using ARIES for SEEA, and over time revisiting the methods and improving them as new data become available. So you can go to ARIES right now, you can register, and you can start to use it yourself using global data, but this is an example of some steps that a national statistical office could take to start to use ARIES more comprehensively, incorporating their own data and models and really generating high quality endorsed results. The last slide I'd like to share is really a vision for where we are in the future. And I'd like to think that in 5 years, just to put a number out there, African nations would be able to produce their own SEEA accounts independently. These would be endorsed by NSOs. These would be populated by their own data. Countries would be able to update their own accounts as new data sets become available at all scales. The estimates would continue to improve as the science evolves, because we would have an active user community that's contributing to new data that can underpin the models. And Africa would be a leader in South-South capacity building exercises around natural capital accounting. I truly believe this is achievable, but I believe we need to come together as a community and find some common vision and work towards interoperability in order to achieve it. And I hope we on the ARIES team can help to do that with all of you. So thank you so much. And I'll close my talk, and I'll leave any time for discussion.
Thank you very much, Ken. That was very useful. And I think the cartoons helped for us to get a better understanding of where we each, what kind of role we each play. Sorry, I forgot to mention this in the beginning, but I haven't been given rights to put my camera on. That's why you can't see me. So I'm sorry about that. But I hope this is still being interesting for everybody. We have had a few more questions in the chat. Ferdinando has addressed the one about the link, how to access it. Thank you, Catherine. So I think if there's another question here, I'll bring it up, and either Ferdinando, Bram, Alessio, or Ken, if you can either raise your hand or just jump in if you feel like they're more relevant to you. So one of the questions is again about data, and I think this may be related to what you mentioned earlier. Who is allowed to and how is local data updated into the system? And I think it's been briefly mentioned, but I wonder whether you could also be discussed, either Ken or Alessio, about the difference between the global and the local data, please. Alessio, would you like to start?
Yes,
Sorry,
if you want, I can answer this question, yes. I think when we think about global and local data, I mean, this is clearly, this is special explicit information which is essential to environmental assessment. When, for instance, I can bring up the case of the land cover maps, which are the first step to do this kind of assessment. And when we deal with global data, we have the advantage that this data is kind of harmonized. So the information is kind of consistent across countries and across times, because these products have been built taking into account to be consistent. And so let's say that a direct comparison is possible with these products. When we use local data, what happens is that they're usually more accurate. So this translates into, for instance, classification that better consider the information that is more relevant in that specific context, which means also that maps or data that is built is better to fit potentially and estimate biophysical modeling in this context. But on the other hand, these local products are usually maybe generated for different purposes and use different methodology, and the methodology and the technologies have been changing over time. So it's not so easy to make a direct comparison of this product over time. So combining and harmonizing this information, it's kind of a difficult task. What's like the solution to that? So first of all, I think is working to make sure that the generation of future data takes into account this aspect, and that data is generated as ready as possible for this kind of analysis. So for instance, for environmental accounting. On the other hand, with our team, we are trying to make the data suitable to compile account. So for instance, when we have cases in which we're giving support to countries that they have local data, which in the beginning, they are not fully consistent, for instance, between years. And what we're doing is to work with them, to adapt them, and to try to identify those inconsistencies and work with them to correct them. And then so that then they can be integrated in the system and can also benefit like the rest of the users. So I see this is like the current path that we are using to introduce local data in the system. Moreover, there is also the role of the UN Global Platform, as Bram mentioned, which I think is, yeah, it's very important. And the final aim is to have that, so to have this container of data that has been endorsed by country and that can be used, in general to democratize this information. And this particular case, for instance, for your community to run and compile environmental accounts. I'm not sure if this answers all the questions because there were others. For instance, I see one that asks if all the data available is free to use and accessible, and that depends on the data owner. Our infrastructure can serve this data, but of course we need the endorsement, and yeah, we need to receive the grant, the permission from the owner of the data to make it available on the system. But once it is inside, yes, this is free for all the users. Taking into account the fact that some data might be kept private because of confidential issues or other reason, we also offer the possibility to kind of work in a protected or private environment within the system. And I think this also addresses the question of how can we handle a private project in ARIES. So both data and models can also be treated in this private environment, or there could be like an hybrid solution, which is to allow some of the users which belongs to a particular groups to access certain information in the system. I think Ferd maybe can explain better this part, but the system has already been set in place, having in mind this kind of flexibility.
Yeah, so maybe I can add something. Basically, yes, as Alessio said, each piece of information, be it data or models or model components, can be associated to a specific set of users or user groups that are allowed to see it. And obviously for us, the best situation is where information is generally available. But if at some point the algorithm hits some needed inputs that are available in two ways. One is private but more precise, and the other is public. Then the user that has the ability to use the better data because it's part of that group will use the other, while the machine will choose another route to get the results for a user that doesn't have access. And this is one side of privacy. There is the other side of privacy. I'm not sure what the question was about, because it could be about both. If you mean a private project, meaning that a project that you use privately and then you use to sell the results or making money or anything like that, then that's another story. And basically, through the normal channels, the sites that we told you, etc., we make every new user sign an agreement that they basically operate and they can do the system for as much as they want without any fee, as long as their agreement is non-commercial, so they don't make money out of that. And we have also a template of a license that for consultants or people like that, they can use ARIES for money, but in that case, they have to enter a specific agreement that is negotiated case by case. And so that's the other side of privacy. If it's private for you, meaning that you want the results to use them privately and then potentially use them for business, etc., that's all possible, but it's not the same route that we are talking about in terms of getting registered, etc. It needs a different license. Anyway, we are completely set up to keep all the sides of privacy as secure as possible. All the connections are secured, and we have individual agreements for data that also might limit the availability of data for some people. Sometimes we can distribute the data outputs, but not the data themselves. So there are agreements that can be kind of complicated, and going through all of them will take a lot of time. But we take the issue very seriously, of course, although we work for the planet, as I always say, not for people. So whatever is free for us, for everyone, is our favorite information, for sure.
If I could just add one more thing, there was a question about how data are contributed, and for the moment, that's using a piece of software called the ARIES modeler. What you saw was the web interface, which Alessio gave the very quick demonstration of. And that's used to access models, produce results, and view results. But there's also a modeler software that's used for scientists to contribute data and models. And again, anyone can have access to that, anyone who's a registered user. it takes a higher level of training and knowledge to be able to use that, because of course you're actually learning to contribute and program data and models rather than just use existing data and models that are on the system. But a user can register, they can create projects which can then be hosted on the web or kept private and personal. And if they're web hosted, they can be shared with the whole world or just with a subset of users. And that's how both data get contributed, but also new models and new content about how and where to use models. So that's within the modeler software, and that generally does require training and a higher level of technical expertise. But we have a variety of resources available and in development for using it.
That is great. Thanks to the three of you. That was very useful. I hope it's been clear for everybody. So there have been a few questions in the chat, but I think they're more related to whether this video will be accessible. And yeah, it's been confirmed that it will be accessible. Maybe we can send a link out to all of you who's registered for this webinar. So thank you for that, and thank you for the interest. I'm wondering if we can either go back to a question that is for Bram, that was brought up in the beginning about the uptake of the system of environmental economic accounting. That was one of the questions. What is the level of adopting the environmental system of accounting globally and regionally? You mentioned it briefly, Bram, beforehand in terms of 90 countries, but is there any more detail that you can share with us about that? Thank you.
Yeah, thanks, Monica. Let me perhaps also drop a link in the chat. So we're doing this annual assessment, and we actually also have, I think, a map in one of our latest reports that shows you, for all of the countries, sort of their status of compilation of SEEA accounts. We definitely also have a breakdown, by regions. And so just very quickly, so we have, I think, 90 countries compiling SEEA accounts, but the majority is doing a form of central framework accounts. We currently have like 36 countries compiling a form of ecosystem accounts. But yeah, I think the number will be expanding quite rapidly. To give an example, also, for instance, in the European area, there is already a directive also for all member states to compile environmental economic accounts, and that will be expanded to also include ecosystem accounts. And then there has been also, I think last week, pretty exciting announcements from the US that they're also going to really jumpstart natural capital accounts compilation. So I think we see these developments across the globe. So yeah, I'll put that in the chat. Thanks.
Thanks, Bram, and thank you for the questions coming in. There is one more question. I don't know if this can be briefly explained, but could you please briefly explain how AI, artificial intelligence, is used within the ARIES framework?
Yeah, that is definitely a question for me. I don't know if I can do it briefly, but I can certainly say something. The AI these days has become synonymous with machine learning, which is really unfortunate because what I always say is that machine learning is actually artificial stupidity, because it's basically a way for looking at data, learning correlations, and then replaying those correlations. So you see something enough times, and then you say, okay, this will be the output because I've seen it already, which is exactly what stupid people do. But ARIES does that as well, because many of the models we run, although not many of the ones we use in the accounting context actually, are based on machine learning. But the AI that is used the most in ARIES is actually machine reasoning. So it's based on the formal statement of knowledge through a number of documents that we call ontologies, and we work a lot on. They're basically a work in progress since the beginning of the project, and will never end, basically, which is what provides the concept, the names, the words for the system, and the relationship between those words. And then you have an algorithm that parses a question like a net value of pollination, for example. That would be an attribute, and then value of, which is an operator that turns pollination, which is a process, into a quality, something like that. And through that parsing, basically we inform a reasoner, which is the machine that starts the search for all the elements that are required in order to answer that question. So that happens through basically the machine inference. So if we don't have a way to compute one particular variable, then the machine can reason and understand that there are other ways to do it by computing something else. For example, if I ask for a presence of mountains and I don't have a layer, a spatial layer that is tagged with presence of mountains, then the machine knows that because a mountain is an object, its presence can be assessed by looking for the mountains themselves, for example, from I don't know, OpenStreetMaps or something, and then building a layer that contains the points where that mountain is, etc. So if you can imagine this process brought to the extremes, is the same process for which at each step in this inference process, basically we launch another search on the network so that more questions can be addressed. And when we have built basically a decision tree that points only to resolve the information data, basically, then you can reassemble that into a model, compute the model, and then give the user the results. And all this happens as you type, basically. So the main artificial intelligence that's used in the system is machine reasoning, and machine learning is used along the way, both to compute some models and also to learn from what users do and improve the resolution process that builds the models as the system gets used. There is a technical note, and maybe somebody can put it in the chat, that explains the technical details much better than this. It's a bit of a long read, but it's not very long. It's like 6 or 7 pages. And there are examples of actually how the system does its reasoning. Thank you, Ken. And how to, and actually also examples of the languages that we use to write the semantic and procedural knowledge that the machine requires to enable this process.
Thank you, Fernando. Yes, that was very, very useful and clear. We appreciate that. So we have 5 minutes left until the end of the webinar. So before we go on to the closure, and the next steps, I was wondering if Alessio, Ferdinando, or Ken could share with us a little bit about the next steps for ARIES. So what functionalities do you expect to be able to include in, let's say, the next 2 years? Like what are the next milestones for you?
That's a tough question, because one important thing that we actually learned from experience and from more senior people is that things should always, I mean, even visions should actually be driven by demand. So there is a lot going on at the moment. For example, we are putting in agent simulation, which basically makes it possible to have behaviors modeled in the system, as well as just variables that change over space and time. And that will give us a lot more flexibility in computing complex models, also models that can branch out to other models that run independently on other machines, so that you can envision institutions or centers that have real-time models of specific phenomena, like, I don't know, human migration, for example, or climate change, etc. And instead of having to compute every time the entire story at each query, you can actually branch out to those models and use the models that are being computed over there in order to integrate and build literally planetary simulations driven by semantics and automatically connected. So from a technical perspective, I think that's the most exciting part. From a more practical perspective, obviously we are committed to ARIES for SEEA and to natural capital accounting and a number of other sustainability related activities. So basically all the SDG realm is likely to be eventually within the scope of what we do. We also had this very important learning experience in developing ARIES for SEEA, which is we basically are special modelers, social environmental biophysical models, and we had no idea of the statistical world and how difficult it would be to connect those two in a proper way. So we learned a lot of lessons there with ARIES for SEEA, and we are applying them so that our models can become more easily a point of reference to build official statistical data. And this includes branching out to the CRCF, the central framework, which is something we are bringing into ARIES, not only for the users to be able to build their own accounting tables with global data as they are doing now, but directly through ARIES, so that they have a common interface for everything, and that is quite moving along quite well, but also so that these accounts can talk to the environmental accounts, and eventually one can inform the other, and more statistical information can be compiled that uses a combination of those two. So I would say that these are probably the directions that we have in mind at the moment. But if you ask me in 6 months, the answer will probably be different. Anyway, if I forgot something, Ken, unless you please fill in the holes for me.
Thank you, Ferdinando. I do hope we're able to talk again about ARIES in the coming 6 months. Alessio, Ken, and Ferdinando, as we bring this to an end, is there anything else that you would like to share before I close?
Not on my side, but I see that Bram has raised his hand. Maybe he wants to.
Thank you. I do not see the raised hands. Thank you. Bram, do you want to talk, or is it an old hand?
Yeah, no, perhaps because I think there were still also a number of questions, and I think Ken and Alessio are also answering some of them in the Q&A. But perhaps very quick, also some responses there, because there was, for instance, a question: who can benefit from ARIES? Is it the governments, NGOs, other corporations? So I think we did discuss a bit, but I think there's many users. So I see definitely researchers, but also policymakers, statisticians as users. But yes, also international organizations and governments and so on. I think there's one thing that may also be important to answer is whether it's possible also for users to add your own sort of vector maps to focus areas of analysis. Because I think Alessio showed, you can select countries, you can also select subnational areas, watersheds, and so on. So I think the answer is with the Explorer, you can really zoom in to sort of the area of interest, but it would still be sort of, let's say, your screen, so a rectangular area, which you can, I think, process afterwards also in, let's say, QGIS and so on, the maps. It's possible to also upload specific shape files if you have a specific area that you're interested in, but I think as Ken answered, therefore you need to use the modeler, and that requires more training and so on. So, but that's definitely possible. I also wanted to just very quickly mention that in addition to what Ferdinando is saying, and I think also there were some observations also from colleagues from Botswana that started experimenting with it. So, ARIES is continuously expanding. So there's now a few ecosystem services that are there, but we're planning, or the BC3 team is also working hard to include also water-related ecosystem services, starting with water supply. It's also it's a beta version. So sometimes, we also discover a glitch in a model or so. I think but then it's, in the new releases, it's being repaired and improved. So yeah, that's very much this community approach that we also really, appreciate feedback from users, and then, the ARIES team can also grow the functionality. So yeah, let me stop there. Thanks so much.
Thank you, Bram. I'm sorry I couldn't see the hand up, but you're right. It was really good that you answered those questions. So I think we will be wrapping up now. Thank you very much, Peter Katanisa, for giving us this time with the community of practice. I think we have all really benefited from the questions, the discussion, and I really do look forward to engaging further with the community of practice. So as the BC3 team has mentioned, this is something that could be used by everyone, but of course it will require time, and their support is available, and they would like to pilot it in as many countries as possible. So I'm wondering whether joint fundraising possibilities is something that could be a follow-up after this workshop, in terms of getting people's times and getting some interest to keep on piloting these accounts. And also, as I mentioned, we'll be doing an in-person training in July. So I'm hoping that once we have those reports and those accounts developed by the platform, we would be able to have another webinar maybe in about 6 months' time. And maybe those countries and those experts who've been able to take part in the training, maybe they could be presenting all these things to all of us to see how that turned out. So thank you very much. This has been very good. We really appreciate having hosted this from the World Bank in Washington and in Rwanda also, Peter and Leona. Thanks, everybody. Have a very good day. Bye.
Thank you.
Thank you, Monica. Thank you, all
Bye-bye.
presenters, and bye-bye.
Thank you.
Everybody. Bye.